school for you, okay? So here we go. This is finding the orthocenter, which is what construction, or what, not a construction because we're on a graph, but what are we looking for? What are we creating? Altitudes, thank you. Orthocenter, altitudes. Okay, do you guys recall how to get an altitude? What does it take to have an altitude?
Ooh, the perpendicular thing.
Yeah, you got it. Perpendicular. So you have to have a perpendicular slope. Okay, perpendicular slope, and it goes through the opposite vertex. So let's go ahead and highlight. Let's do the easy one first. Anytime you have a horizontal or a vertical line, those are the easiest ones to find. So do that first. What is horizontal to vertical? Or sorry. What is perpendicular to vertical? And that would be horizontal. Okay, so that's why this is an easy one to do. Kind of tilt this in your head. If I had a piece of string and I was dropping it down, if I tilted this, could you see this is where the altitude would lie? So if you can turn your paper, that might be easier to see. But one altitude goes from the blue vertex horizontally to the blue line. Okay, then at this point you just pick another vertex and another side. So just any one you want is fine.
The bottom one.
Go with the bottom vertex?
Yeah.
Okay.
Or no, the bottom side.
Okay. Bottom side to the top vertex. All right, so if we're going to go perpendicular to this pink side, you have to use a perpendicular slope. So you need to find the pink slope and then flip it and negate it, right? It's the opposite reciprocal. So here's the slope. What's the slope of the pink line? Is it just one? Yeah, so is it positive or negative? So the slope of the pink line is negative because it's going down. Negative 1 over 1. So what's the perpendicular slope to that? 1 over 1. So at the pink dot, you apply the slope of 1 over 1. Notice how they intersect at a coordinate point. That will happen for you on the assessment as well. So notice how it's a perfect connection right there. So it's at negative. So negative 4, 3. There's your orthocenter. That's your orthocenter. Yep.